may have one time or another heard about measures of central tendencies. So when we say measures of central tendency, we are basically referring to the three M's: the mean, the mode, and then the median. These are the basic terms that we use to measure central tendency. So what is it? These three things, what are they all about? So basically, the mean help us to find the middle or the average number or the average value of a set of numbers. So if we have 10,000 different values for different entities, we want to find the average. And basically, in a situation where we have about, let's use 100. So we have 100 different samples or individuals, and we are taking their age. Now, for us to be able to tell a simple story about these 100 people, we can use their mean or their average age. So just say or tell someone listening to us that this class of 100 people, the average age of these people is this. And how do we come about the average or the mean? It's simply the sum Sorry, I understand my slide is not showing. Is it showing now? Right. So yes, so I was talking about descriptive statistics, and I mentioned that measures of central tendency is one of the descriptive stats that one undertakes when we are trying to describe the bulk of data. And the measures of central tendency that we have includes mean, median, and then the mode. So the three M's. Now, I was trying to help us understand what mean is. So another name we can give for mean is average. And so when you have a set of 100 people in a particular environment, and you are asked what is the age of this particular set of people, you wouldn't go ahead and be mentioning the individual names of participants of that community or area and be mentioning their individual ages. It wouldn't make sense, or it would take a long time to get that done. And so to get the mean or the average, you basically add the individual ages of these individuals or the 100 participants and divide by the number of people, which is 100. And this is basic mathematics we all have learned. Now, when it comes to the median is also simply the median value of a set of numbers when it is arranged in increasing or decreasing order of magnitude. So when we have a set of continuous variable or discrete variable and we want to find a median, it's simply we arrange it from the highest to the lowest or the lowest to the highest, and then we find the middle value. In a situation where the set of values or variables involved even what we do is that we add the two values that are in the middle and divide by 2. However, when we have it at being an odd number, the middle value will be the value that falls in between the set when we divide it according to 2. And so we can equate the median to the 50th percentile value. So it's important that we have this knowledge because some of the statistical packages won't give us median values. But once we understand that median is also the 50th percentile, once we have 50th percentile value provided by the statistical package, we can be able to say that that is our median. That's it for the median. And then the mode is simply the most occurring value among a set of variables or values. It's simple as that. But when we come to research purposes, for that matter, biomedical research, most of the measures of central tendency that we employ is basically mean and then median. Now, it's important for us to use these two because of issues of what we'll be discussing subsequently. So another measure or descriptive task that is performed is the measures of dispersion. And the measures of dispersion just help us to see how the variables or the data points we have differ from one another. So we can have statistics like standard deviation, variance, range, quartile ranges, and all that. These are ways in which we can be able to tell the dispersion that occur in a set of values. And the most popular one that is used is the standard deviation. So I wouldn't bother us with the formula for calculating standard deviation and all that. The statistical packages that we have would just calculate that for us and without we having to stress ourselves. You know, if you listen to the talk by Robert Ago, he rightly mentioned that we humans now are getting lazy and we want things done at a very faster rate. And that is why we employ things like AI in our day-to-day activities. And so, unlike or instead of we going manually taking calculator and calculating these things, statistical packages are here to help us do that. Lastly, the third aspect of descriptive statistics that we consider is the distribution. So how is the set of data you have distributed? Now, this brings our mind to the Gaussian normal distribution. Now, the Gaussian normal distribution has it that a distribution is bell-shaped, and that 95% of the time we will likely have variables behaving normally, and then the rest 5%, so 2.5 at the extreme ends, will represent variables that are likely to deviate to the left side or to the right side. Now, having that normal distribution that happens in nature in mind, we want to see whether our data set, any data set that we obtain from a naturally occurring environment, does that data also follow that distribution? That is where the distribution comes. So here we measure things like kurtosis, skewness, and then normality testings or assumptions are explored. So briefly, I mentioned things like kurtosis and then skewness. I want to spend a few minutes to digest a little on the kurtosis and then the skewness. So basically, kurtosis, the spelling is Kurtosis. So it's basically talking about the thickness or the flatness of a distribution. So how thick is it and how flattened is it? That is what kurtosis focuses on. And there are mathematical formulas that are used in doing that. I think there's someone on the call that's right. So I've just muted the person. Yeah. So kurtosis, there are mathematical formulas that are used to derive that. And basically, when a data set is normal with kurtosis, or then the peak is normal and the flatness is normal, it has a value of 3. And when that happens, we'll see the distribution is mesochaotic. So when you hear statisticians mention things like mesochaotic distribution, it means they are trying to say that the kurtosis value is 3 and that it is normal in terms of peak and flatness. Now, we can also have a positive kurtosis value or a negative one. When we have a positive one, it means that the values are higher above the standard value, which is 3. And so we can say that distribution is peaked. And another name for the positive ketosis is the leptoketic. So a distribution can be said to be leptoketic when it is positive in terms of peakness. And then the final way of describing the ketosis is the negative or flat curve ketosis. So this happens where our values are lower and up or below the standard value, which is 3. And we can call it the plateauketic distribution. So we have mesoketic, normal, leptoketic, which is positive, and then plateauketic, which is negative. To have all these 3 terms in mind, and as we do our demonstration, we'll come to see how we can use these terminologies to describe the various data sets that we have. Now, when we come to skewness, the skewness also talks about the degree of asymmetry of the data series that you have. So when you divide the distribution into half, that's what appears on the left equates to what appears on the right. So is there a mirror image? That is what skewness has to do. And your distribution can either be normal with 0 skewness or be positively skewed where we have long right tail, or also be negatively skewed where we'll have a long left tail. So these are the 3 main situations that we can have as far as skewness of data is concerned. It is either normal, positively skewed, where we have the right tail longer, or negatively skewed, where we have the left tail being longer. So basically, these are things that we can use to describe our data, ranging from measures of central tendency, the dispersion, and then the distribution. Now, I mentioned that there's a need for us to know the median and then the mean, because it applies when we are trying to work with data that does not follow normal distribution. And so in making decisions on which of the measures of central tendency to use, we have to make sure that our data sets, we know that it is either normally distributed or not normally distributed. So when it is not normally distributed, then we'll go for the median option. But when it passes test of normality, that is to say, it is normally distributed, then we'll go for the mean option. So these are the dynamics that one, as a statistician, needs to really understand when handling data. It is one thing to know what to do, but it's also one thing to know how to go about that. So it's not about having a statistical tool and clicking things to give you outputs, but you need to have mastery over what you are doing and know why you are doing what, so that in case your analysis goes out there to someone and questions are raised, you can be in position to defend it. That is not all. It also gives you confidence to defend whatever you have presented. Right, so having said that, we want to see how we can first use Excel to work around these measures. We'll then move to a JAS platform. We'll also go to the GraphPad Prism. We also use SPSS to explore that. We also use Theta, and then we'll also use Python. So these are the 6 different statistical packages or tools that we'll be exploring at the end of my session. So without wasting time, I'll go to the Excel platform. So so if you can see my screen, you can let me know. I reacting to the call. Right, I think we have about 11 participants. That is fine. Quite a number of people are interested to know how to go about statistical analysis, especially when it comes to biomedical research. And I'm really interested and fascinated about such. So that is why we have organized this program. Now, when you listen carefully to what we discussed yesterday, we mentioned that as a statistician, you don't have to work on the original data. You always create a working data set to manipulate with. So here we have a data on age and then biochemical markers of particular set of patients. So what do we do? The first thing is that we don't work on the original data. So we click and then create a working sheet. So I will usually name this working sheet. Since you are learning from me, it's likely you also do the same. So I copy this and then, so I copy Control C, or you highlight everything and then right click and then you copy. Then you come to the working sheet and then you paste. So once you have pasted, you have your data there, and then you come here, you right click and create or insert a space here where we are going to, and then you scroll down and then we'll put in here. So first we are calculating mean, and we also calculate median, and then we also look at standard deviation. Yeah, basically we'll do this with SPS, with Excel. So we are going to input a function. Functions always begin with an equal sign. So we enter equal. Mean is the same as average. So once you type AV, the series comes for you to select what you need. And we selected average. We'll click here and then we'll drag it up until we get to the last value that we want to include in the series. And then we enter, or you click on enter. And once you click on enter, you realize a value has been generated. What it means is that the mean, right? You realize that when I shift up, the labels of the various columns disappear. So in order to get that fixed, we'll come to view and then we'll come to freeze. So we'll freeze the top rows so that when we scroll, they don't disappear. So we'll scroll down and then, so realize that in describing this, we can say that the average age of this set of people, which is about 197, is 50.25 years or 50 years. And if we want to calculate the average or the mean for the various parameters, i.e. BMI, FBG, fasting blood glucose, TG, which is total cholesterol and all that. I don't want to bother all of us with the technical names, but simply for you to do same for the remaining columns, we just come to the lower part of the rectangle over here, and then click on it and hold and drag across, and then you release your hand. By doing that, you realize that the same equation that was here reflects here as well. And so it calculates for you the average or the mean for all the parameters you're looking at. So this is one easy way you can be able to navigate around calculating the mean or the average for whatever parameter you have. Now for the median, you click on equal to, which is the function to tell Excel that whatever you are going to input there is going to be a function. So you should regard this as a function. So you type median. So once you type median, you come here, you repeat the same action that we did for the median, and then you click on enter. You realize it gives you a median value. You drag this to the end, and it gives the concomitant median value for each of the columns that were considered. We equally do same for standard deviation. So standard deviation, we have standard deviation of the population, standard deviation of the sample. We'll select that for the sample, but we are working with a sample out of the population. The difference is population, you are considering all the people at a particular setting. But when we are looking at sample, we are taking a representative number from that population, from about whom you can infer to the general population. And there are statistic methods in coming out with sample size from a given population. So here we are working with a sample, and so we'll calculate sample standard deviation. Now the sample standard deviation also takes into account degree of freedom. Degree of freedom is basically n minus 1, that is the sample minus 1. So we scroll it up, and then we enter, and then we see our standard deviation. Yeah, so basically, this is how you can be able to get your mean, median, standard deviation using Excel. So one would ask, why would I do this, and how would I represent this to someone to read? Basically, we represent the mean and then the standard deviation together. So it is represented as mean plus or minus the standard deviation. Now, one may also ask about, well, I wouldn't go into that. I wanted to mention some other complex formulas, but I think it is beyond this discussion, so I'll keep it. Subsequently, we'll mention that. So yes, this is basically how we can be able to use Excel as a tool to generate your mean and your median and your standard deviation values. I usually will use Excel because it gives me the leverage to get it done quickly, and also help me to concatenate and add a plus or minus very fast and present it in a tabular form for presentation purposes. But you can equally get it from other statistical tools. So at this point, we are moving to the JAS platform, and then we'll see how we can equally do what we have done here.